Hello, student. Here gonna continue to the chapter 23 after we see how to represent the circuit in the symbolic form. And we're gonna learn some basic tools. We already started in chapter 23 talking about the Kirchhoff current or Kirchhoff laws in general. And we mentioned about the Kirchhoff junction law, where we have the summation of the input current. They are equal summation of the output current from the junction. So here is we call it a junction. So in this case, here is the I1 comes in equal those two current comes out. So that's the law. And the second law that we're gonna cover in chapter 22, here what we call it the Kirchhoff law, loop law, which basically from the names considered a closed loop. So in a closed loop, the summation of the voltage potentials, algebraic summations equal 0. So here is the equations regarding for this particular circuit. I have delta V1 comes from the batteries, and then delta V2 comes from the resistor 1, delta V3, delta V4, and this algebraic summations. So even though he plus, but when you write it down with the numerical value, you have to consider the sign. So which one is positive, which one is negative, okay? So here is, if you wanna just explain it to you more, what we mean by delta V2, delta V3 across the resistors. Let's assume you have here is the R2, and we have here is the R3, and we have here is the R4. Now, how to find the delta V? In that loop, it has one single current I. So the Ohm's law to find the delta V across the R2, basically just current times R2 in this case. Delta V3, basically the current times R3. The delta V across the V4 or across the third resistance or 4, current times R4. That's what we mean by delta V and delta V for each resistor. That's how we calculate it. Algebraic summation in this case equals 0. Again, algebraic. So algebraic means dependent about the sign, positive or negative. If you want to just imagine it more, I have, for example, 10 volts here, and this 10 volt should be divided in the 3 values, dependent about the resistors. This one is gonna be 2 volt, this one 3 volt, this one should be 5. So that's the algebraic summation. So include the positive or negative sign. Let's see an example for that. If you are given a circuit with the 10 volt batteries connected with the 2 resistors. So by the way, this is the real shape of the resistors. That's what we have. It just usually, and those strips, they are the code to find the value of each resistors. So now let's see. So the questions here asking for what the current through those 2 resistors. Again, we're gonna go to the summations talking about the current. IN equals summation of I out. That's our law, or that's our formula we need to satisfy. Now let's go and see where is the current comes in, where is the comes out. If I look at here, all the current here, there is no junctions. So the current going the same path. There is no in and out. So what that means the current is gonna be the same current in all the loop. Again, inside one loop, there is no junctions that lead to the current will be divided. So I have the same current in entire loop. The second example here, the same circuit, but we're asking you to find the voltage. In this case, we're gonna find the summation of the delta V equals 0 in that case. And we're gonna go back to here is the delta V1, and here is the delta V2. Again, it is loop, so it's the current. It has the same current. To find each delta, let's see, delta V1 equal the current I with amps times the resistors 10 ohms. delta V2, the current has the same value, amps, times 50 ohms. So here from these two equations here, if you look at the delta V, it's proportional to the value of the resistors. So here is the 10, so 10 times I. But here is the 50 times. So basically delta V2 is gonna be hold more voltage here. Again, when we have the series resistors, the voltage is proportional to the value of the resistors. Okay, so he didn't ask you to find it, you can find it numerically, but here is just general estimation. We can find or end up with these calculations. The current through the 50 is larger than 10. So from that perspective, we're gonna go to the first connections that we can find it in any electrical circuit. That the connection we call it the series connections. So series connections, that means I have electrical circuit and contains many resistors, and those resistors connected in series. How to identify the series connections? The resistors are wired one right after other. So here is the R1, R2, and R3, one after other. Okay. Now, this is the most important table you need to consider, guys. What kind of the properties, what kind of the facts that it's valid when I'm talking about the series connection. The first one, the current through the series connections should be the same. So the current through R1, the same current through the R2. The voltage across the resistors is not the same, as we see in previous example, is proportional to the resistors. The another one, adding more resistors lead you to the current will be less, or the decrease the current. Those three facts you have to make sure you're understanding when you are dealing with series connections. Okay, here is an example for that. We have two circuits, and one circuit has 10 amps and 50 amps connected with the 10 volt as a source, and the second circuit 10 volt connected with the 60 amps. How we can compare those two circuits, which one has large current. So basically, again, this one series connections, the current, it should be the same. And here, here is the current I1, here is the current I2. Since the current is proportional for the resistors here, I have two resistors, 10 and 50. So the total resistance, the current will face 10 plus 50, 60 amps. What about second circuit? The current I2, he gonna face one resistor, but that resistor is 60 amps. So as 60, it is 10 and 50, so they are the same. So basically, both current, they will be the same in both the circuit. Just because of the 50, 60, just equal 10 and 50 resistors. Now, a second, or the new terminology that we're gonna learn today, what we call the equivalent resistors. When I have the series connections, multiple of the resistors connected in series, I can represent those resistors in one single resistors. We call that resistor is equivalent resistors. How we can find it? Just adding those resistors, they are connected in series, and you end up with the one single resistors. Okay, so in that case, give you the most simple circuit dealing with or make your analysis in it. Let's solve this example here for very quickly here. We have what the current and the voltage through each resistors in the circuit. Let's see what do we have. We have the current through the 12 and 15. We know this one in series, so I know the current should be the same current. So basically, I can find my R equivalent, which basically R1 plus R2, and this one will be 17 ohms. Oh, sorry, 27 ohms. Okay. So now I have 27 ohm. I can represent my circuit in equivalent perspective. Sorry, my pen acting up a little bit. So here is the R equivalent, which 27 ohms, and here is the voltage 10 volt, and here is the current, still my current here. So I can use the Ohm's law. The current will be voltage divided by R. I'm talking about, yeah, voltage divided by R. How much I have volt? I have 9 volt divided by 27. 27 ohms. I end up 1/3 volt divided by amps, which 1.3 amps. Okay, now since I have series connection, so this is one will be 1/3 amp, the same current in this one 1/3 amps. Asking for the delta V, I know delta V1, which basically I times R1. I have the current 1. I have the current 1/3 amps times R1. I have 12 amps. I end up with the 4 volt. Delta V2, which basically is supposed to be equal 5, but let's calculate it, because 9 is 4 volt comes here, so the second 5 volt will be in the 15 ohms. Let's confirm that. So this one is the I times R2. I have I 1/3 times the resistor is 15 ohm. 15 ohm. I end up with the 5 volt. So that comes the delta V again. Delta V equal delta V1 plus delta V2. That's still valid for my, so this one should be 4 volt. This one should be 5 volt. Okay. So I am done with this lecture today. We have series connections and 2 identical bulbs. So that means the bulb, they are the same. What happened to remain the bulb when one replace it with wire? So what happened here, when I have reduced the light bulb by 1, so what that means, here is the R, if you want to assume here is the R1, and here is they are identical, R1, and here just R1. What happened when I did this one here, guys? The R decrease. The R decrease means here is the, let's call it, this one is 2 and this one is 1. Here is the I2 and here is the I1. And in this case here, I2 larger than I1. Since the current is large, again, for the power, I squared times R, so proportional to the current. So what happens, so we have more power, which one gonna be consumed more? I have more current comes here. So the circuit or the light bulb in the circuit number 2 will be more bright. So get more bright. This one. Okay, this is the ending of the second video, guys, and see you next video. Thank you so much.